All right, so we've done some discussion about function notation and evaluating functions at not just values but expressions. And we have talked about this graph, right? And I want to reiterate that when we look at point P, we know that it's a comma f of a for x comma y coordinate. And then if we look up at Q, it's a plus h comma f of a plus h. And we've talked that we can find the slope, right? We can find the slope. We know that this is h for a run, and we know that this is f of a plus h minus f of a for the rise. And that'll give us the slope of that average rate of change between P and Q. So what's that look like, though? We haven't done an actual problem yet. So I wanted to do an example today. And we're going to use this function, which is a quadratic, all right? So it's a parabola, but we don't need to have the graph of it. And we're going to do the slope between these. So that curve, you know, it might look something like this, right? And what we're going to find is this rate of change between P and Q. So what's that look like? Well, often students get confused because there are three distinct parts happening here. We have the f of x plus h part. We subtract the original function f of x. And after we do the difference on the top, we divide by h. All right? H should always cancel out if it's a function. So when we're done, we will expect nothing in the denominator but 1. So I'm going to do this by parts because we're going to have to know that f of x plus h, right? We're going to have to know that. So we'll do that, and I'll underline it in blue here. So that's what? Well, that's x plus h squared plus 2 times x plus h this time. All right. Binomial squared is going to be a trinomial. And I'm going to get x squared plus 2x plus h squared. We also know when we distribute the 2, we're going to get 2x plus 2h. All right, it might feel like overkill here, but I really want to be clear about this. So I'm going to underline this in green. And we know f of x. F of x is just x squared plus 2x, right? That doesn't change. If it was f of n, we'd just put that in there, but it's that thing. So now we got to take the blue minus the green. And I do need to take the time to set this up, because if we don't set it up properly, we do end up with some problems. All right? So I'm going to try to keep the colors here. So I'm going to say find that. So I'm going to write x squared plus 2x h plus h squared plus 2x plus 2h. I'm going to put in parentheses for a second because when I do the subtraction, we got to be really careful here. So I'm going to subtract f of x. But remember, if you're subtracting f of x and it's in parentheses, the sign's going to change in all the terms. All the terms. And this is all over h. And that's still going to be in black. All right? So that's the problem we have. Now, I have an erasure board, so this is great. So I don't need the parentheses here. That's a positive 1. And I'm just going to distribute the negative here, and I distribute it there. So those become negative terms. Now, here's what I was talking about. If this is a function, and that is a function, it passes the vertical line test, you're going to notice that anything that doesn't have h cancels out. And now we're left with this. And you notice that there's h in all the numerator function terms. So I'm going to factor out an h. All right? I need a little more board space. So I'm going to factor out that h. And here's what I get. I factor out the h, and I get 2x plus h plus 2. Because I took this h, and this h out. Okay, just one of them. That's still over h. Now I can cancel an h because it's h times. And so my solution, all right, for this, in terms of x and h, for the average rate of change on this curve is 2x plus h plus 2. It's a tough problem. You got to manage the details, all right? But if you keep working at it, I'll try to get a view so we can see it all. And again, it's a long problem. It is a long problem. But we can do it, okay? And again, it's just practice. And the big thing here is to really track those two independent functions. Make the substitutions, know what you're doing before you try to set up and subtract. All right, we're going to practice this a lot. It's going to be on a lot of our things that we do because, it's, again, this is a huge part of calculus.